Lesson 35, Hypothesis Testing Procedure for Two Population Means. Example 2. Is there a difference between the mean GPA of Sierra College Elementary statistics students that rate their mathematics ability as above average and below average? Use the Sierra College Elementary Statistics Student Survey and a 5% level of significance to address this question. Now, there are two possible answers to this question. Either yes, there is a difference between the means, or no, there's not a difference. Statistically, we answer these types of questions using hypothesis testing procedures, because we're going to either say that yes, this idea is valid, or no, this idea is not valid. Now, the idea is there a difference, which can be expressed symbolically as a not equal, between the mean GPA, which can be expressed symbolically as mu, of Sierra College Elementary statistics students that rate their math ability as above average, which is one population, and Sierra College Elementary statistics students that rate their mathematics ability as below average, which is a second population. So we can express this idea symbolically as mu1 not equal to mu2, indicating that there is a difference between the mean GPAs, where 1 represents the first population, or the students that rate their math ability as above average, and 2 is the second population, which are students who rate their math ability as below average. So, in this example, we'll be conducting a hypothesis testing procedure involving two population means. So, the following steps will be used in order to conduct our hypothesis testing procedure, starting with the stating of the hypothesis statistically. Here we found that the mu1 not equal to mu2 indicates of yes, there is a difference. The opposite idea, no, would be the mu1 equal to mu2, because if mu1 equals mu2, they're not different. Actually, they are equal. Now, the equal is always labeled as the HO, and the not equal is always labeled as the H1. So the stated hypotheses here symbolically is the HO is mu1 equals mu2, which would lead to an answer of no, there is not a difference, versus the H1, mu1 not equal mu2, which leads to the answer of yes, there is a difference. Next, we state alpha, the level of significance, and we're using the customary alpha of 0.05. Now, the 2SAMP t-test command on the Ti84 calculator can be used to calculate the p-value that we need to reach our decision. But to calculate the p-value, we need our sample results. So on the Sierra College Elementary Statistics Student Survey, question 3 asks the students, how would you rate your ability as a math student? And question 5 asks the students, what is your college GPA? Here we need to separate the GPAs of the above average students and the students who rate their math ability as below average. So our first population were the students who rated their math ability as above average. That was coded with the number 3 for question 3. So as we look up all the students who rated their math ability as above average and look up their corresponding GPAs under question 5, we get the following results. So recording these results, we can find that the GPAs of students that rated their math ability as above average were 2.9, 3.5, 3.6, 3.3, 3.5, 3.8, 3.0, and 3.2. Now, we look up the GPAs for the students who rated their math ability as below average. That was coded with the number 1 for question 3. So looking up the GPAs for all the students who rated their math ability as below average, we get the following results. So we can record these as GPAs of students that rated their math ability as below average. We had 3.8, 3.7, 2.2, 3.9, 3.1, 2.9, 2.8, and 2.0. So here we have our two sample results. So these two samples can be entered into two lists in the Ti84 calculator. To do this, we press Stat and then enter the editor. I'm going to put the first sample in list 1 and the second sample in list 2. And since I have some old data, I'm going to arrow up to the list name and press clear, enter. Arrow up to the list name and press clear, enter to clear out list 1 and list 2. So the first sample enters in list 1 by going 2.9, enter, 3.5, enter, 3.6, enter, 3.3, enter, 3.5, enter, 3.8, enter, 3.0, enter, and 3.2, enter. The second list is where we enter our second sample. The GPAs were 3.8, enter, 3.7, enter, 2.2, enter, 3.9, enter, 3.1, enter, 2.9, enter, 2.8, enter, 2.0, enter. Now both of these sample sizes are not sufficiently large, so we need to check that we have a reasonable normal or bell-shaped distribution for the population from which a sample was collected. To do this, we can make a histogram to show the shape. To do that, we press second, y equals, enter, to enter the statplot command. The statplot is turned on, the histogram is selected, and XList, the data that contains our GPAs in the survey, was question 5. So I go second, stat, to get my list, arrow the cursor to Q5 for the GPAs, press enter to select. So now I'm going to make a histogram of these GPAs. But now I need to set up the window. So I press window. The Xmin, the minimum GPA, was a 2.0. Xmax, max GPA, well, GPAs can go to max of 4.0. And the X scale, I'm going to go from 2 to 4.0, counting by 0.2 GPA units. Now the y-axis is the frequency, so the minimum y is 0, and the maximum frequency is, we don't know, but our best guess is in the sample size divided in half. So 44 divided in half is 22. Going from 0 to 22, I'll count by 2s, so my y-scale is 2. To see the histogram, we then press graph. And here it seems reasonable to assume that the distribution of the GPAs are bell-shaped, because it is low on the ends, high on the middle, and it's somewhat symmetric. Although it does seem to stretch a little more in the lower GPA direction than the higher GPA direction, it still seems reasonably bell-shaped. So even though the sample sizes of N1 equals 8 and N2 equals 8 are not sufficiently large, since the distribution of the populations from which the samples were selected reasonably follows a normal or bell-shaped distribution, the hypothesis testing procedure, which relies on the results of the central limit theorem, can be applied. So, continuing with our hypothesis test, we can go to the 2samp t-test command by pressing stat, arrow over to tests, and arrow down to 2samp t-test. Enter. Here we have for input the actual data. So we arrow over to data, press enter to select, then down arrow. Our first sample was entered into L1. Our second sample was entered into L2. Freak 1, freak 2 is 1 because each GPA came from one student. And H1 in this test includes a not equal to. So we put the cursor on not equal and press enter to select. Pooled is no because we are not using the pooled approach. And then down arrow to calculate, where we press enter, and we could see the calculated p-value. In this case, the p-value rounded to the nearest thousandth is 0.305. So now that we have our p-value, we can make our decision. Since the p-value of 0.305 is not 0.05 or less, the decision is to not reject HO. In this case, we do not reject HO because we do not have enough evidence to contradict it. And when we do not have enough evidence to contradict HO, that also means we do not have enough evidence to conclude H1. So Based on our results of our hypothesis test procedure, we can now give our conclusion or answer to the question. Therefore, there is not enough evidence to establish that there is a difference between the mean GPA of Sierra College elementary statistics students that rate their mathematics ability as above average and below average at the 5% level of significance. The results are inconclusive, and more data is necessary to address this question. So it would be better if we were to have bigger sample sizes, because we may have enough evidence to more clearly conclude what the results are.